All right, so we're going to go ahead and finish up 8.0. So we've already talked about, the main idea here is simplifying radicals. You need to make sure that you have all of your perfect squares memorized. That's what's highlighted in purple there. So 1, 4, 9, 16, 25, etc., because those are the numbers you're looking for to fit into the radicand to see if it simplifies. So you always want to pick one of those numbers. Okay, so we're going to go ahead and take a look at 8.0b. So just a review of some of your algebra skills. We know how to multiply with distribution. So A times the quantity C plus D is AC plus AD. We also have another method where you have 2 terms times 2 terms. That is called FOILing. So you would first multiply A times C. So the FOILing means the first terms. So that would get you AC. Then you would multiply the outer terms. So that would be A times D. So this is outer. Oops. Then you would do B with both of the terms. So then you would do the inner terms. B times C is BC. And then L is the last terms in each of the 2 sets of parentheses. And B times D is BD. And then if possible, you would try to simplify. Reminder, if you see something like A plus B squared, that is the same thing as saying A plus B times A plus B. A common mistake I will see is students think that's A squared plus B squared. That's incorrect. Because of the plus sign in the middle, you cannot distribute that squared. You cannot use the exponent rule there. So once you end up actually multiplying this out, A times A, our first term, is A squared. The outer and the inner would give you AB times AB, so you end up with 2AB. And then your last terms are B times B, which is B squared. So kind of a trick to remembering to multiply something like A plus B squared, which is called perfect square trinomials. You're going to square the first number. So that's how we got A squared. Then you're going to square the last number. So B is the last number. And when you square it, you get B squared. And then everything is multiply everything very fast. So you're going to multiply 2 times A times B. And that gets you that middle term there. So that's just another way to kind of go ahead and do that one quickly. Okay, so let's go ahead and get started. I'll do a few of these and then I'm going to let you try some too. So multiplying the following polynomials. So here we're multiplying, distributing in the 3x, making sure when you distribute, the exponents go up. So 3x times 4x squared is 12x cubed. When you multiply, you do not need like terms. When you add or subtract, then you need like terms. Okay, our second arrow, 3x times 5x is negative 15x squared. Your exponent goes up when you multiply by an x. 3x times 10x is positive 30x, and you're done. These cannot be added. They are all have different terms. They're not like. Okay, example 2 is a FOIL example. So first, you're going to FOIL 2x times 3x. That's 6x squared. Outer, 2x times 4 is 8x. Inner, negative 5 times 3x is negative 15x. And then last is negative 5 times 4, and that's negative 20. Notice that these middle 2 terms here are like terms, so you can simplify that. Positive 8x minus 15x is negative 7x. So you do need to simplify your answer completely. Okay, number 3 is the problem we were talking about, multiplying perfect square trinomials. So let's go ahead and give that a try. I will do it both ways that I described up there. You can do the quick way, which is square the first. So 3x squared is 9x squared. And then you would square the last. So 7 squared would be 49. And the middle term, you'd multiply everything, literally 2 times 7 times 3x. So that would give you 42x. And you'd be done. If you wanted to go ahead and actually write out 3x plus 7 times 3x plus 7. Oops, I lost my 3. And you did 3x times 3x, that's 9x squared. 3x times 7, that's 21x. 7 times 3x is 21x. 7 times 7 is 49. These two terms combine. You get the same thing. So again, square the first, square the last, multiply everything very fast. That's just a little trick to do it quickly, but you get the same answer either way. All right, I'm going to have you stop and pause me, and please try number 4 on your own. All right, welcome back. I'm going to go ahead and give this one a try. So I'm going to do the quick method. I'm going to square the first. So 5x squared is 25x squared. I'm going to square the last term. 4 squared is going to be a 16. And it's a -4 times a -4. So it ends up being positive. So I am going to take that into account. It's -4 times -4. The middle term is multiply everything. So I have a 5x, I have a -4, and I have a 2 I'm multiplying. So that's everything that you're multiplying together. And that's going to give you a -40x. So again, that's just the quick way to go ahead and do it. You are more than welcome to go ahead and actually write it out, which is 5x minus 4 times 5x minus 4. You would get 25x squared minus 20x plus 16. The minus 20x and minus 20x would turn into a -40x. So you end up with the same thing. Either way is totally fine. Okay, so we're going to be multiplying with radicals and with mainly square roots. So let's go ahead and take a look. So square root 88 times square root 88. You could actually multiply 88 and 88, but you would get a very large number. Notice 88 and 88 are the same. So that makes it a pair that can be pulled out. So 88 times 88, this is a perfect pair. So you can pull this out. So it's just going to be 88. Number 6, the square root of 77 squared. A square root and a square undo each other. So it's just 77. That's one way to think of it. Or you can think of, if you're squaring something, that's like 2 of them. Since square root 77 and square root 77 are the same, again, that's like one pair that you could pull out. So it's just 77. Okay, 5 root 3 times 5 root 3. I always say inside with inside, outside with outside. So when you're multiplying, so 5 times 5, you can actually do 5 times 5 is 25. Root 3 times root 3 is the square root of 9. And we know the square root of 9 is really 3. So 25 times 3 is 75. There is no radical in that answer. You are done. Okay. So really all we did, we're going to be applying to number 8 as well. If you notice, they're very similar, except now we have 2 sets of those. So we have 3 root 2 squared. Again, that's like saying 3 root 2 times 3 root 2. 3 times 3 is 9. Root 2 times root 2 is root 4, and the square root of 4 is 2. So in our first one, we really have 9 times 2. For the second part here, we have 2 root 7 squared. So that's like saying 2 root 7 times 2 root 7. 2 times 2 is going to be 4. Root 7 times root 7 is root 49, and the square root of 49 is just 7. So we really have this type of problem. 9 times 2 is 18. 4 times 7 is 28. 18 times 28 is going to give us 504. Okay, that is different than number 9. Notice in number 9, all of a sudden we have a plus sign here. That is different, just like foiling. You cannot distribute the squared to each of these. That would be entirely wrong. So instead, this is actually a FOIL. So we have 3 plus 5 root 2. So again, that is like saying 3 plus 5 root 2 times 3 plus 5 root 2. Now you can't use any shortcut here. You have to just FOIL this out. So the first term is 3 times 3, which is 9. Our outer term is 3 times 5 root 2. 3 times 5 is 15 root 2. Inner, 5 root 2 times 3 is going to give us 15 root 2. And then the last terms is 5 root 2 times 5 root 2. So you really have 5 times 5, which is 25. Root 2 times root 2 is root 4. And the square root of 4 is really just 2. So that's really just going to become a 50. 25 times 2 is really just a 50. So we have 9 plus 15 root 2 plus 15 root 2 plus 50. So we've got 9 plus 50. Those are like terms. That's 59. And then 15 root 2 and 15 root 2, which we talked about in our last section, that you can add things when they are common. Those are common. 15 root 2 and 15 root 2 are common. That's going to end up being a 30 root 2. 15 and 15, you add the 15 and the 15. Root 2 stays the same. And we'll actually talk more about that on the next page. Okay. Wonderful. Let's keep rolling. So now it's the adding and subtracting. So here's we're going to talk about a little bit more. So if you have 2 apples and 5 apples, when you first learned about like terms, you would say, okay, well, that's 7 apples. 2x plus 5x. Okay, the x and the x are the same. So 2 plus 5 is 7 with the x. 2 pi plus 5 pi. We do that a lot in geometry. They are like terms. They both have a pi. 2 plus 5 is 7. And then you continue the pi. So again, you need a common or like terms have a common variable and the same exponent if there is an exponent. None of those had them. Here, root 3 and root 3 are the same. So you're actually going to do 2 plus 5, which is 7, and then the root 3 stays the same. So when adding and subtracting radicals, combine outside numbers. You can call those coefficients if you want to, but that's what we did in this problem right here. 15 and 15, we added that to 30, root 2. Okay, simplify the following radicals. Again, they need to be like terms. So 11 root 7 minus 5 root 7 are like terms. They're both root 7. 11 minus 5 is 6, root 7. You cannot do anything with the 3 root 2, so it just stays. You cannot combine those. Also try to simplify. Root 7 and root 2 do not have a perfect square in them, so you're done. Okay, next one. First of all, I can't combine anything, but I can simplify. So square root 75, we know breaks up into the perfect square that fits into it is 25, and 25 times 3 is 75. We know that the 25 comes out and turns into a 5, and then we still have a root 3. So 2 times 5 is 10 root 3. For the root 8, we know root 8 breaks up into the perfect square 4. 4 goes into 8. And again, if you want to write them at the top, 4, 9, 16, 25, 36, 49, etc., you can go ahead and do that. So 4 times 2, the 4 comes out and turns into a 2. And that other 2 is stuck inside. So that becomes minus 8 root 2. The third piece, 32, breaks up into, maybe I'll make this a little bit smaller. There we go. 16 times 2. Again, I picked 16 because it's one of my perfect squares. So we can break down the 16. It turns into a 4. So the 4 comes out, the 2 stays in. 3 times 4 is 12, root 2. Whoa, awesome. Notice here that I have a root 2 and a root 2. So those are going to combine. I cannot do anything with the 10 root 3. It doesn't combine, but I can do negative 8 plus 12. I want to make sure you see that negative sign. And that's going to be a positive 4 root 2. When you're adding and subtracting, the roots do not change. The number inside the roots, the radicand. Okay, let's do a little bit of distributing here. So here we're going to distribute the root 3. So root 3 times 4 root 2 is going to give us 4 root 6. 3 times 2 are inside, so you can multiply. The next one is root 3 times root 12. 3 times 12 is square root 36. Yay, look at that. 36 is one of our perfect squares. The square root of 36 is 6 with no radical. It is a perfect square. And you cannot combine those. So you would write your answer just exactly like that. Okay, so let's keep looking. Solving radicals. You're going to see some problems where you're going to be solving radicals in your homework. You're getting x by itself, just like normal. So if it was a normal equation, you know, you would subtract 22 from both sides. And I'm going to show all my steps. So we would be left with 4x equals negative 2 minus 22 is negative 24. And then when you're solving for x, you would want to go ahead and move over the 4. So you would divide by 4 to both sides because it's connected by multiplication. Negative 24 divided by 4 is negative 6. So you've done a gazillion of these problems. So now let's apply that with radicals. Here we're trying to solve for x root 3. Notice the x and the root 3 are attached by multiplication. So to undo multiplication, you are going to divide by root 3. So what ends up happening is we're going to get x equals 12 over root 3. And maybe some light bulbs are going off in your head because we need to rationalize. We cannot have root 3 in the denominator. Can't have a root in the denominator. We talked about that in the last section. So to get rid of it, you're going to have to multiply by root 3 over root 3. Again, it doesn't get rid of the 3. It just gets rid of the root. So 12 times root 3 is going to give us 12 root 3. The bottom, root 3 times root 3 is root 9, which is really just the square root of 9 is 3. Don't forget to check to see if you can simplify. We can. 12 over 3 is really 4 root 3, and that's our final answer. We have now solved for x. X equals 4 root 3. Okay, in our next problem here, again, we're trying to solve for x. This is the left, this is the right side. The problem is the 2 root 6 is on the left side. We need to move it to the right side so that we can get x alone. So the very first thing you're going to go ahead and do is add it over to the other side. So I'm going to say plus 2 root 6 plus 2 root 6. Lovely. Negative 2 root 6 plus 2 root 6 is gone. I bring down my x root 2. Wow, look at this. I actually have like terms. They're both root 6. So 3 plus 2 is 5. The root 6 stays. Again, x root 2 is connected by multiplication. So to undo multiplication, you have to divide by root 2 to both sides. Lovely. So they cancel on the left and I have just an x. This is actually a very nice problem because I can simplify 6 over root 2. They're both in square roots. So I can go ahead and simplify. Could you rationalize and multiply by root 2 over root 2 and simplify? You would get the same answer as me. But I'm going to go ahead and use this easier way. 6 over 2 is 3. And it's in the root. And that's my answer. All right, wonderful. And that is the end. And then we will start doing some geometry applications with our next section.